Have you ever imagined what it would be like if the entire Earth turned into a giant snowball? Not just the polar regions, but the equator too, frozen solid. Oceans locked beneath thick sheets of ice, continents buried under glaciers, and life hanging on by a thread. It sounds like a scene from a science fiction movie, but this is something that many scientists believe actually happened multiple times. In Earth's distant past. This is the incredible story of Snowball Earth, one of the most extreme climate events in our planet's history. In this video, we'll dive into the evidence, the causes, and the astonishing consequences, including how this icy catastrophe may have helped give rise to complex life. Snowball Earth refers to a time during the Proterozoic Eon, roughly 720 to 635 million years ago, when it's believed that our planet experienced global-scale glaciation, meaning ice reached all the way to the equator. This wasn't your average ice age. Modern ice ages leave the equator mostly warm and tropical. But during Snowball Earth, even equatorial regions were buried under glaciers several kilometers thick. Imagine a world where even the oceans were frozen over, possibly to a depth of 1 kilometer or more. There are believed to have been at least 2 major Snowball Earth events, the Sturtian Glaciation, around 717 to 660 million years ago. The Marinoan Glaciation, around 650 to 635 million years ago. Some researchers suggest there may have been others, but these two are the best supported by geological evidence. How do we know this happened? Well, the Earth keeps a pretty detailed record if you know where to look. Geologists have discovered glacial deposits in places that today are warm and tropical. For example, in Namibia, Canada, and Australia, rocks formed from ancient glaciers have been found near the equator point. One of the strongest pieces of evidence is the presence of drop stones. Rocks carried by glaciers then dropped into ocean sediments when the ice melted. These are found in sedimentary layers that date to the Snowball Earth periods and were clearly formed in marine environments near the equator. Another clue comes from cap carbonates, unusual layers of limestone that appear directly above glacial deposits. These likely formed when the planet rapidly warmed and the oceans released massive amounts of carbon dioxide, triggering a global carbonate precipitation event. Taken together, these clues suggest that massive glaciers reached sea level near the equator and that the planet underwent an extraordinary freeze and subsequent thaw. So, what could have caused our entire planet to turn into a snowball? One leading theory is the ice albedo feedback loop. Here's how it works. Ice and snow reflect sunlight. This is called albedo. As temperatures drop and ice spreads, more sunlight is reflected back into space. Less sunlight means more cooling, which causes more ice, which reflects more sunlight, and so on. It's a runaway feedback loop. Once it starts, it's incredibly hard to stop, but what starts the cooling in the first place? Several factors may have contributed. Around this time, continents were clustered near the equator, which could have disrupted ocean currents and reduced heat transport from the tropics to the poles. Also, weathering of newly formed mountains might have pulled CO2 out of the atmosphere, cooling the planet. Another idea involves volcanic activity. If volcanic eruptions released aerosols into the atmosphere like sulfur dioxide, they could have blocked sunlight, causing temperatures to drop. Eventually, Earth may have passed a tipping point, cooling so much that ice spread unchecked, and the entire planet entered a deep freeze. Now you might be wondering, how did life survive? Earth during snowball periods would have been an incredibly hostile environment. But not all life vanished. Some simple organisms like photosynthetic bacteria may have survived in isolated pockets of liquid water, perhaps beneath thin ice near volcanic hotspots or in shallow areas warmed by geothermal heat. Hydrothermal vents on the ocean floor could have provided warmth and nutrients to sustain life. These vents are teeming with microbial communities even today and may have been critical refuges during Earth's frozen phase. It's also possible that thin equatorial sea ice allowed some light to penetrate, sustaining photosynthesis in areas where the ice wasn't as thick. Life hung on, but just barely. And this long freeze may have shaped the evolutionary pressure needed for what came next. So, how did Earth escape this frozen nightmare? The answer, once again, may lie in volcanoes. Even during Snowball Earth, volcanic eruptions continued. But since the oceans were covered in ice, there was little weathering or rain to absorb the CO2 from the atmosphere. Over millions of years, CO2 levels slowly built up like a greenhouse ticking time bomb. Eventually, the concentration became so high that it reversed the cooling. The greenhouse effect kicked in hard. Temperatures skyrocketed. Ice began to melt. And as the planet thawed, carbon dioxide levels remained high for some time, leading to extreme heat and heavy rains. This rapid change left a signature in the rocks, the cap carbonates we mentioned earlier. These formed in warm, CO2-rich oceans that followed the freeze. The thaw didn't just return Earth to normal, it changed life forever. In the wake of Snowball Earth came a dramatic burst of biological activity. The Ediacaran and Cambrian explosions. These were periods when life rapidly diversified, giving rise to complex multicellular organisms, including the ancestors of animals we see today. Why did this happen? One theory is that the post-snowball environment created the perfect storm for evolution. Oxygen levels rose after the thaw, making it easier for larger, more complex life to thrive. New ecosystems emerged in warm, nutrient-rich waters. The long freeze may have wiped out weak competitors, clearing the way for innovation. In a way, Snowball Earth acted like an evolutionary reset button, pushing life to its limits and then unleashing an explosion of diversity. Could Snowball Earth ever happen again? Probably not in the same way. Today, the continental layout is different and human-driven greenhouse gas emissions are rapidly warming the planet, not cooling it. The biggest threat now is global overheating, not freezing, but the Snowball Earth story is more than ancient history. It's a powerful reminder of how fragile and dynamic Earth's climate system is. Tiny shifts, like a drop in CO2, can lead to massive planetary change, and as we face our own climate challenges today, it's worth remembering that nature doesn't always change gradually. Sometimes it flips suddenly and dramatically. The Snowball Earth hypothesis is one of the most extraordinary tales in geology. A story of catastrophe, resilience, and transformation. A frozen world that almost ended life, but instead helped create the world we know today. Thanks for watching. If you enjoyed this deep dive into Earth's frozen past, give it a thumbs up, share it with friends, and subscribe for more fascinating science stories. Until next time, stay curious.